In this video, we'll present our results of the analysis of NDVI time series data to understand vegetation greening in Ecuador. After watching this video, you'll learn how Ecuador fits into the broader picture of tropical vegetation greening. Let's hear from Bryson.
To study long-term patterns in vegetation greening, we calculated seasonal standardized NDVI anomalies using z-score transformations. But what does that all even mean? As we have learned, NDVI is a great tool to study forest phenology and how forests change across seasons. However, in order to understand the long-term changes in NDVI, such as those related to climate change, we need to reduce the seasonality of NDVI in order to capture the long-term trends. This was accomplished by capturing NDVI anomalies. In simple terms, we transformed NDVI by calculating the overall mean between 1982 and 2010, and then subtracting the NDVI value of each year from this mean and dividing the resulting value by the standard deviation of the data. Sounds cumbersome, but the rationale is simple. If no variation in NDVI exists, the difference between the overall 1982 to 2010 mean in each year will be equal to 0. Conversely, if the value of this difference for a given year is different from 0, it indicates that this year was a dramatic outlier from the overall trend. It's as simple as that. Year NDVI anomalies show us how different a year was from the overall 28-year trend. This graph depicts NDVI anomalies between 1982 and 2010. The y-axis shows a scale ranging from -1 to 1, with 0 at the center. The x-axis shows years studied in this research. The different colors denote the different regions of Ecuador, explained in previous sections. The Ecuadorian Amazon, or Amazonia, is green. Coastal Ecuador, or coast, is blue. And the East and Andes are black and red, respectively. If there were no differences in NDVI, and therefore changes in greenness, all of the dots would align with the 0 line. However, the majority of dots representing different years are not aligned with the 0 line, indicating differences. Now, an important question in this research, and the science in general, is whether the observed differences are statistically significant. In the case of this NDVI anomaly data, we ask if there are significant breaks in the time series that indicate higher variation in NDVI anomalies than we would expect through random chance. The answer to this question is yes. We used the Petite test to identify significant changes in the NDVI anomaly time series. In this graph, the dotted vertical lines indicate the years where we identified significant breaks. We can observe that despite some variation, all regions exhibit breaks in the time series around the mid-1990s. Some set of changes happened then that caused significant shifts in NDVI across much of Ecuador. In summary, this graph provides valuable insights regarding NDVI trends between 1982 and 2010 in different regions of Ecuador. Specifically, it shows that there are significant differences in NDVI anomalies over time. Overall, the graph suggests that NDVI was lower during the 1980s and late 1990s, and increased during the late 1990s and early 2000s. This finding is consistent with global greening trends reported in other studies that indicate the tropics are greening, or at least greened up, during the last half of the 20th century in response to climate change.
In this video, we discuss long-term change in vegetation greening in Ecuador. We use NDVI data from 1982 to 2010. For your own reflection, think what has happened since 2010. We put more carbon in the atmosphere, and the tropics reacted by fixing more carbon. However, at some point, there may be a limit at how much carbon tropical forests can fix. Think about one cannot consume food beyond a certain point. Is that something that is happening with tropical forests?